All right, so you're here because you want to get to the bottom of something big and you want to get there quick.
Yeah.
And we're diving into a pretty huge story today, this whole push to make more advanced computer chips right here in the U.S.
Exactly. And we've been digging into this really insightful CNBC report, trying to understand why this is happening, who's involved, and what kind of roadblocks they're facing.
Yeah, makes sense. And this report, it really gives us a good look at two major pieces of this puzzle. So first up, we're going to zoom in on Micron. They're the last big U.S. company making memory chips, and they've got some seriously ambitious expansion plans.
Right.
Then we're going to head down to Texas. Seems like it's becoming a real hotspot for all kinds of chip making.
Definitely becoming a hub, yeah.
But we can't really talk about any of this without looking at like the bigger picture, right?
Yeah.
All those global tensions, especially with China and Taiwan, and then the CHEPS Act, throwing some serious cash around those. Those are major factors pushing chip production back to the U.S.
Oh, absolutely. Those are the big drivers.
So for us, it's all about pulling out the key insights, right? Making sure you, the listener, get a clear, engaging, and hopefully pretty fascinating look at this whole complicated issue.
That's the goal.
All right, let's jump in. Let's start with Micron and the absolutely essential world of memory chips. What's the deal with them?
Well, what's really interesting is that Micron's the only major memory chip maker left that's actually based in the U.S. Like, they're the main source for those crucial DRAM chips, the dynamic random access memory, the stuff our devices need to process data really fast.
DRAM. Yeah, I mean, that's the speedy but kind of fickle memory our computers and phones use for whatever they're working on right now, right? Needs a constant power supply to hold on to information.
Exactly, yeah. It's like your computer's short-term memory.
Right, right. And then there's that other type, the NAND flash memory. That's what we find in solid-state drives and memory cards. The kind that remembers things even when the power's off.
Right, non-volatile, holds your data even when the device is powered down.
Yeah.
And, you know, Micron's not just sitting around, they're actually undertaking these massive expansion projects. Like in Boise, Idaho, they're building this new fabrication plant. It's going to be over 600,000 square feet. That's like 12 times bigger than their current facility there.
12 times. Wow, that really gives you a sense of the scale of this whole thing.
Huge, yeah.
But it's not the only big project they've got going on, right? They're doing something even bigger in New York, right?
Yeah, up in New York State, Micron's planning on building 4 of these huge 600,000 square foot fabrication plants. This is a $100 billion investment spread out over the next 20 years. It's actually the biggest chip project in U.S. history. And this commitment's getting a boost from incentives offered by New York State. And of course, they're hoping to tap into some of that federal funding from the CHEPS Act.
So what's driving this huge growth spurt for Micron? I mean, all this hype around generative AI that seems to be a big part of it, right?
Oh, definitely. The report says Micron's stock has jumped over 30%, fueled by all the excitement about generative AI. Those fancy AI models, like ChatGPT, need tons of memory to handle all the data they work with.
Makes sense. All that brain power needs a place to store its thoughts. And the report mentions something called HBM, high bandwidth memory. What's that all about?
Right, HBM. That's Micron's most advanced memory product, designed specifically for AI applications. So it basically packs a ton more memory into a smaller space while also moving data faster and using less power.
Ah, so it's efficient.
Really efficient, yeah. And here's the thing, for every super powerful CPU or GPU that gets all the attention, you need multiple memory chips working behind the scenes.
So even though individual memory chips might not be as complicated as a CPU, you need so many of them, it takes up a ton of space, right?
That's right. The article even pointed out that memory manufacturing actually needs more physical space than any other kind of chip making.
Oh, interesting. And we're talking serious precision here, right?
Oh, absolutely.
I mean, Micron's NAND and DRAM devices, they're working at the 15 nanometer level. That's tiny.
Unbelievably tiny. Like a human hair is about 3,000 times thicker. That's why you see all those workers in those bunny suits and these factories. Even a speck of dust or a stray hair could mess everything up.
So those suits are not just for show.
No way. It's like performing surgery, but on a microscopic level.
Wow. Now, the report also mentioned how much the memory industry has grown overall. It's a much bigger slice of the semiconductor pie now.
Way bigger. At the start of the century, memory was maybe 10% of total semiconductor revenue. Now it's somewhere between 25% and 30%.
Wow.
Basically, anything that computes needs memory. And as AI keeps getting more advanced and more common, that demand's just going to keep rising.
Makes sense. It seems like the memory market's also become a lot more consolidated over the years. Not a place for the faint of heart, huh?
Definitely not. The report said there used to be something like 20 major memory chip makers. Now there are just 3 big players globally: Samsung, SK Hynix, and Micron. To survive in this game, you got to be pumping out high-performing products at a competitive price.
It's a tough business. And Micron itself, they've been around for a while, right? They have a pretty interesting story, starting out in the basement, right?
Yeah, in the basement of a dental office in Boise, Idaho, back in 1978. Pretty humble beginnings. And within a few years, they developed this groundbreaking 64K DRAM chip. That was a game changer. They went public in 1984 and have been navigating this really cyclical memory market ever since. The report calls it a feast or famine kind of situation.
Right, so booms and busts.
Exactly. Right now, there's an oversupply, but eventually things will shift and we'll see an undersupply.
And that brings us to a pretty big challenge for Micron, right? Their dependence on China.
Big time.
About 25% of their revenue comes from China, and they're kind of caught in the crossfire of this whole U.S.-China tech battle.
Right in the middle. China's put restrictions on some of Micron's sales over there, citing cybersecurity concerns. And the U.S. has also limited what American chip companies can sell to China, especially when it comes to advanced tech. It's a complicated situation.
So Micron's really walking a tightrope. It sounds like they're trying to reduce their exposure to China by branching out.
Exactly. They've started building a $2.75 billion facility in India for assembly and testing. That's a clear move to reduce their reliance on the Chinese market.
Makes sense.
It's also worth remembering that Micron has a history with these U.S.-China trade tensions. Like back in 2018, there was that case involving Fuji and Jinhua, a Chinese company, and allegations of intellectual property theft. Micron takes their innovation seriously. They have over 54,000 patents.
Wow. So all this ties into Micron's big plan to really ramp up DRAM production in the U.S.
Yeah, big time.
Right now, only about 2% of the world's DRAM is made in the U.S., and it all comes from Micron's plant in Virginia. They want to boost that to about 15% in the next 20 years.
A huge jump. And these giant factories they're building, they need a ton of resources, especially energy and water. Each of Micron's new fabs will use as much power as 25,000 homes.
Wow.
But here's an interesting thing. The report says the cost of renewable energy in the U.S. is actually about 25% lower than in Asia.
Huh. That's surprising.
Yeah. And as for water, each of those New York plants is going to use the same amount of water as 25 Olympic-sized swimming pools every single day. But Micron is planning to recycle about 75% of that water on site. It seems like access to fresh water from the Great Lakes and low-cost renewable power were major reasons they chose New York for these new plants.
So it's all very strategic. But there's still challenges, right? I mean, making these high-tech chips in the U.S., is it really more expensive than doing it in Asia?
The report says that, yeah, labor and materials are more expensive here in the U.S., and setting up these advanced factories costs more too, but that gap's shrinking. And there's another issue, skilled workers. Even if you have the money, you need the people. TSMC, the company that makes most of the world's most advanced chips, they've been having trouble finding enough qualified people for their new factory in Arizona.
So having the right people is key.
Totally. Micron seems to be on top of that, though. They're partnering with universities and running these chip camps to train new workers.
Smart move. Okay, so Micron's making a big bet on the future of memory and on bringing chip production back to the U.S. Now let's switch gears and head down to Texas, which seems to be turning into another big hub for chip making.
Absolutely. Texas is booming.
I mean, Silicon Valley is still the place for chip design and all that, but Texas is where they're actually being made.
For sure.
And it's not a new thing for Texas either.
No, not at all. I mean, the integrated circuit itself that was invented at Texas Instruments back in 1958, so Texas has a long history in this industry.
Wow, the very first integrated circuit right there in Texas.
Yeah.
So what makes it so attractive for chip companies now?
Well, according to the report, there are a few key things. Land's cheaper, and there's plenty of it. Texas is very business-friendly, easy to do business there, good access to ports and the materials they need. And the overall cost of doing business is just lower compared to a lot of other places.
So it's like a perfect storm of good stuff.
Yeah, pretty much.
And it's not just one company investing there either. It's like a whole bunch of big players setting up shop.
A whole ecosystem. Samsung's investing $17 billion in Taylor. Texas Instruments is putting a whopping $30 billion into Sherman. And then you've got companies like Infineon, Global Wafers, NXP, Applied Materials, even design centers for Apple and Amazon. It's a real hub of activity.
And I bet, just like in Micron's plants, they got to keep everything super clean, right?
Oh, absolutely. Ultra clean.
I remember the report talking about Class 1 clean rooms. What's that all about?
Those are seriously controlled environments. The air is constantly filtered and replaced, like every 8 seconds in some places. They can't have even the tiniest bit of contamination. One Texas Instruments executive said that even an eyelash on a microchip would look like a space monster under the microscopes they use.
No space monsters allowed.
Definitely not.
So let's talk specifics. Texas Instruments, they're not just the calculator company anymore, are they?
Not even close. They still make those graphing calculators that everyone knows, but they're a huge semiconductor company now. They've got like 80,000 different products and serve about 100,000 customers in all kinds of industries. We're talking analog chips, power management ICs, all sorts of components that are probably in every electronic device you own.
Wow.
Yeah, their RFAB2 facility in Richardson, along with their other fab there, they're aiming to produce 100 million analog chips every single day.
Every day. That's a lot of chips.
A ton. And that $30 billion investment in Sherman, that's for a brand new, super automated factory designed to work with 300 millimeter silicon wafers.
What's so special about 300 millimeters?
With these bigger wafers, they can make way more chips per wafer, which makes them more efficient.
Efficiency.
All about efficiency, yeah.
All right, how about Samsung? They already had a big presence in Texas, right?
Yeah, they've been in Austin since 1996. They've got a massive factory there that's now mostly focused on making logic chips for other companies. That's called a foundry. And they expanded their Austin operation with another fab back in 2007. But their new project in Taylor, that's even bigger and more ambitious.
Is massive.
1,200 acres. And the first fab they're building there, it's a $17 billion project. And it'll be their first in the U.S. that can make the most advanced chips. Cutting edge stuff.
So Texas is really becoming a center for both memory chip production through suppliers to Micron and others, and for all these other essential types of chips too.
Yeah, it's the whole package.
And it sounds like Texas is really rolling out the red carpet for these companies, right?
Yeah.
All those business-friendly policies.
Oh, totally. No state income tax, sales tax breaks on manufacturing equipment, and other incentives. Plus, Governor Abbott signed the Texas Sheech IPS Act, which adds another $1.4 billion in state subsidies specifically for chip making and R&D.
So they're serious about attracting this industry. And this whole push to bring chip production back to the U.S., it's about more than just economics, right? I mean, there's a national security angle too.
Yes.
Especially after all those supply chain problems we saw during the pandemic.
Absolutely. The pandemic really exposed how much the world relies on chips made mostly in Asia. And it's not just our phones and computers, it's national security stuff too. Military comms, weapons systems, all that. As of 2021, 92% of the world's most advanced logic chips were made in Taiwan by TSMC. And with all the geopolitical risks there, it's a wake-up call for the U.S.
So we need to be less reliant on other countries.
Exactly.
And the U.S. share of global chip production has really fallen behind. It used to be 37%, now it's down to 12%. That's why the federal CHIPS Act was passed, to try and reverse that trend and boost domestic manufacturing.
Right. And since the CHIPS Act was passed, there have been over 50 new chip-related projects announced across the U.S. worth over $210 billion.
Wow.
And a big chunk of that is going to Texas. Over $61 billion in projects are already underway there.
So Texas is winning big.
Yeah.
And it's not just the giants like Samsung and TI either. The report mentioned Global Wafers making a big investment in Sherman. What do they do?
Global Wafers is a Taiwanese company, and they're putting $5 billion into a silicon wafer factory in Sherman. Silicon wafers are the base material for all chips, so it's a crucial part of the whole supply chain. And apparently Texas had to compete with Ohio and South Korea to get that factory. Shows how much demand there is for this kind of manufacturing.
It's a global race. Now, water keeps coming up as this really important resource for making chips. And Texas, they've had some serious drought issues, right?
Yeah.
So how are they handling the water needs of all these giant factories?
That's a big concern. Making advanced chips takes thousands of gallons of super pure water every minute. The report said that the government in Sherman has been buying up water rights to make sure there's enough in the future. And companies like Samsung, they're doing a lot of water recycling, aiming to reuse billions of gallons a year. The newer factories are also designed to be more water efficient.
So they're trying to be more sustainable.
Definitely.
And then there's the power consumption. I mean, these factories use a ton of electricity. The report said that those cutting-edge EUV lithography machines, they can use up to 1 megawatt of power each. What are those machines and why do they use so much power?
So EUV stands for extreme ultraviolet lithography. These machines use incredibly short wavelength light to etch superfine patterns onto those silicon wafers. Those patterns are what create the transistors on a chip. And to do that, they need these really complex and precise optics and powerful light sources, which all use a ton of electricity.
Wow. So it's a power-hungry process. The report also mentioned that Samsung actually has its own natural gas power plant in Texas to help meet its energy needs. But that makes you wonder about the reliability of the Texas power grid, right? Especially after that big blackout they had in 2021 during that winter storm. It affected some chip factories in Austin.
Yeah, that's a valid concern. Governor Abbott has said they've made a lot of improvements to the grid since then, but when you've got these critical operations that need so much power, reliability is a big deal. And those 2021 outages did cause some disruptions for chip makers in Austin.
It's a risk they have to consider. So even though the chip market has cooled down a bit recently, which has hit companies like Intel and Samsung, it sounds like those big fab expansion projects in Texas are still going ahead as planned. Samsung's Taylor site, for example, they've still got a ton of empty land so they could expand even more in the future.
That's right. It's all about playing the long game. These investments are driven by national security concerns and the expectation that demand for even more sophisticated chips is just going to keep going up.
Right, makes sense. Okay, we've looked at what's happening with memory chips and Micron and the whole chip-making scene in Texas. Now let's talk about a company that's super important to the whole industry, even though they don't actually make chips themselves. Let's talk about ARM.
ARM. Yeah, they're an interesting one. They're based in the UK, and they design the basic architecture for tons of chips around the world. Basically, they create the instruction sets, the brain of the chip. They don't make the physical chips. They license their designs to other companies and get a royalty for every chip that's sold using their tech.
And when the report says ARM is pervasive, they really mean it. They called it the most pervasive CPU in history. It's in billions of devices every year, especially smartphones. Pretty much every smartphone uses ARM.
Yeah, over 30 billion chips shipped annually, and their customer list is like a who's who of the tech world. Apple, NVIDIA, Google, Microsoft, Amazon, Samsung, Intel, TSMC. Almost everyone uses ARM's tech in some way.
So they're kind of the unsung heroes of the chip world.
In a way, yeah. And there's been this big shift towards ARM's architecture in recent years, mainly because it uses less power than the older x86 architecture that Intel and AMD have traditionally used.
So they're more efficient.
Way more efficient. And we're seeing them being used in all kinds of new devices, like Apple's M-series chips in their Macs. Those are ARM-based. Amazon's using custom ARM chips in their data centers. Qualcomm's Snapdragon processors are now making a move into PCs using ARM. And even NVIDIA and AMD are supposedly looking into making ARM-based PC chips.
So even the big chip companies are embracing ARM.
They kind of have to. ARM is just that good.
It wasn't always smooth sailing for ARM, though, right?
Yeah.
The report mentioned that NVIDIA tried to buy them, but it didn't work out.
Yeah, that was a big deal. NVIDIA offered $40 billion for ARM, but it got blocked by regulators and ARM's own customers who were worried about competition. So in the end, the deal fell apart, but ARM bounced back and went public recently. One of the biggest IPOs in recent history.
That was a big one. So how does ARM make money? It's like a two-pronged approach, right?
Right. About 60% of their revenue comes from royalties, basically. They get a small fee for every chip that's made using their tech. The other 40% is from licensing fees. Companies pay ARM for access to their design blueprints so they can make their own custom chips based on ARM's architecture.
Makes sense. But ARM's not the only game in town anymore, right? There's this new open source competitor called RISC-V. Could that be a problem for ARM?
RISC-V is definitely gaining some traction. It's this open and free alternative to ARM, and some of ARM's big customers are starting to use it. It's appealing because it gives companies more control over their chip designs, but the report says RISC-V is still behind ARM in terms of how mature it is and the software that supports it, but it's being used more and more in things like low-power devices and Internet of Things stuff.
So it's one to watch. But that move by Apple, ditching Intel's chips and going with their own custom ARM-based chips for their Macs, that was a big moment for ARM, right?
Huge inflection point, the report called it. It showed that ARM's tech was powerful enough for high-end devices, not just smartphones. And now there's even a lawsuit going on between ARM and Qualcomm over Qualcomm's acquisition of Nuvia and the ARM licenses involved. It's all very messy.
That's complicated.
Intellectual property is a big deal in this business.
It's high stakes. So ARM's also expanding into other areas beyond phones and computers, right? Like servers and self-driving cars.
Oh yeah, they're branching out. They've got their Neoverse platform for servers and AVA for autonomous driving. Those are big growth areas for them. And we're seeing more and more companies that aren't traditional chip makers like Amazon and Apple and Microsoft. They're designing their own custom ARM-based chips, gives them more control over their hardware and can save them money in the long run.
So it's like a whole new trend. But just like Micron, ARM's got some geopolitical risks too, right?
Okay.
Especially with their business in China and the whole situation with ARM China.
Right. ARM China is kind of this independent entity, and it's had its share of internal problems. Plus, RISC-V is gaining popularity in China, which could be a long-term threat to ARM.
So China's a wild card.
Always a wild card. And even though smartphone sales are down globally, which could hurt ARM's royalty income, they're making up for it by expanding into other markets and getting more money per phone.
So they're adapting.
Gotta adapt to survive.
And finally, the report talked about the talent war that's going on in the chip industry. It's not just about having the money to build these factories. It's about having the skilled workers to run them and design the chips.
Absolutely. TSMC, they've said publicly that they're having trouble finding enough qualified engineers and technicians for their new factory in Arizona. That's slowing them down. ARM is trying to get ahead of this by working with groups like the Semiconductor Education Alliance to train the next generation of chip workers. And with all this growth in AI, the demand for CPUs and therefore ARM's architecture is just going to keep exploding. The report put it pretty bluntly. You cannot do AI without a CPU.
Makes sense. So, wow, we've covered a lot of ground today. Let's recap the key takeaway.
Big takeaways, yeah.
There's this huge push to bring advanced chip making back to the U.S., driven by geopolitics and economics. We've got Micron leading the charge on memory chips, and Texas becoming a major hub for all kinds of chip manufacturing.
And we can't forget about companies like ARM who design the fundamental tech that makes all this possible.
Totally. But this is a really complex undertaking, and there are still challenges. It takes a ton of investment, and it needs huge amounts of water and energy. Plus, there's global competition, geopolitical tensions, and this constant need for more skilled workers.
It's a lot to juggle. So here's something for you, our listener, to think about. Given all the resources and the global competition in the chip industry, what kind of unexpected innovations or changes might we see in the future? How will this reshoring effort impact America's position in the tech world and the global balance of power? These are big questions with big implications for the future.
Big questions indeed. That's it for our deep dive this week. Thanks for joining us.
Thanks for listening.